Alright, so welcome to the day 4 notes on equilateral and isosceles triangles. First thing we're going to do today is we're going to take a look at, we're just going to try and write some things down. We can classify triangles by angles, and we're going to write some things down about those triangles and maybe draw some pictures, okay? So let's first look at an acute triangle. So what does acute mean? It means that all the angles, and here we'll do this with some actually nice handwriting. Pay no attention to that loud beep. Okay, so all the angles are less than 90, so there's that. Ooh. There we go. So all angles are less than 90. And then if we wanted to draw a picture of an acute triangle, something like that. All those angles are less than 90, so there's my acute triangle. Okay? An obtuse triangle. An obtuse triangle is one angle, or one angel, is greater than 90. Okay? One angle is greater than 90. So if we're going to draw that one, I would draw something like this. So one angle is greater than 90. All right? A right triangle. A right triangle, one angle, is equal to 90. Okay? So let's draw that one. And to make sure that I have that one, I'm actually gonna label this as being a right angle. Okay? And then an equiangular triangle. An equiangular triangle is a triangle where all the angles, there's my picture of it, all angles are 60 degrees. Okay? So all angles are 60 degrees, and that's that one right there. Let's go ahead and mark those angles congruent, because if they're all 60, they're all congruent, so we can mark those. All right? Classifying triangles by sides. Okay, so by sides. Scaling is no two sides are the same. Okay. Come back to all the pictures in a second. Isosceles, two sides are congruent. And equilateral, all three sides are congruent. Okay, so let's draw these. For the scaling, just as long as, just as long as it's clear that none of the sides are the same. If I'm not sure whether or not I've drawn that successfully, I can always just label it. Okay, I can always just say, well, this one right here is 6, 7, 8. So that's scaling. Isosceles, two sides, and we can just mark them congruent. And then an equilateral is the same as an equiangular. And I can just mark all three sides congruent. Okay? Use the triangles below. Write the letter of each triangle in the correct circle or circles. Go ahead and pause the video right here. Do this on your own and get some answers, and then we'll check them. Go ahead and pause the video now. All right, you've unpaused. Hopefully you have answers here. Let's take a look at what I got. Boom. There's how I sorted them. All right. If you didn't get those, make sure you write something down. Make sure you go over that with us in class. The sum of the interior angles for any triangle is 180 degrees, right? 180 degrees. So we can use that to find the value of x pretty simply. Okay. So for this one right here, we would simply take 180 minus 42 minus 53, and we get x equals 85. Okay, so x equals 85. Here, 30 and 30 make 60, so this one, x has to equal 120. Over here, this is 90, and that's 42, so I just do some simple subtraction, and I get x equals 48. If you're lost on any of those, make sure you make note of it somewhere so we can get that question answered in class. The triangle exterior angle theorem, we've talked about this before. So we know that the exterior angle is equal to the sum of the remote interiors. And if we wanted to write that out as a formula, let's put some numbers in here. So here's the exterior angle. Here's the interior remotes. So angle 1 equals angle 2 plus angle 3. Okay? So these problems then happen really quickly. Go ahead and pause the video, get some answers for X here, and you can unpause and I'll share my answers. Go ahead and pause the video now. All right, so here's my answers. I got X equals 100, X equals 65, X equals 27, and X equals 10. If you got something other than what I got, try the problem again. If you're still getting something different, make sure you ask in class, especially on these second two right here. This one and this one, these ones, they were kind of difficult. So if you have a question on those, make sure that we do that in class on the board. All right, the isosceles triangle theorem. That theorem says that if the legs of a triangle, let's say if two legs, are congruent, then the base angles across from those legs are also congruent. Okay, and that's an if-then statement. So we should really easily be able to write the converse. If the base angles across from two legs are congruent, then the two legs are congruent. Okay? Base angles of an isosceles triangle are congruent or congruent. All right? Angle bisector for isosceles triangles. An angle bisector for isosceles triangles. If a line bisects it's the non-base angle. Okay? The non-base angle. Then the line is also the perpendicular bisector of the base. Okay? Perpendicular bisector of the base. All right? So if this bisects this, which there it shows they're congruent, then wherever it hits, it not only hits at a 90-degree angle, but it divides those into two congruent segments. Let's take a look at some example problems from all of this. All right? First, let's find two things to find x and y. Okay? On this one, to find x, we know that it may not look like an isosceles triangle, guys, but it is one because the two base angles are congruent. Okay? So I know that 180 equals 40 plus 2x. So x equals, it's got to be, we subtract 40, divide by 2, and we get 70. Here, I'm just going to do 4y minus 1, because if those are congruent, these are congruent. 4y minus 1 equals 3y plus 2, so y equals 3. Go ahead and try the bottom one on your own. Pause the video here and try the bottom one on your own. All right, hopefully you've tried it, and hopefully your setup looked like this. 5x plus 8 equals 2x plus 20. And hopefully you got x equals 4. If you didn't, you need to ask. Over here, if these are congruent, I know that this is y also. So I know that 2y equals 72. So y equals 36. If the setup or the solution there gives you trouble, make sure you put a star by it or a circle around it or a broken heart. And make sure you ask in class. Here, what type of triangle is the triangle below? Okay, and how do you know? Well, let's see. We have these two angles marked congruent. Okay, this is 46 and that's 44. Those add up to 90, which means all that's left for this is 90. Okay, this angle here is marked congruent to that. All these things, it has a ton of characteristics of an isosceles triangle. Okay. Now, and the characteristics are the base angles are congruent, and the angle bisector is perpendicular to the base, or perpendicular to the opposite side, okay? Find the values of x and y. Well, if this is 90, we know that x equals 90. And y is congruent to that, so y is 46. Y, good Lord. Okay, 90. That's it. Properties of equilateral triangles, okay? A triangle is equilateral if and only if the triangle is equiangular, okay? So let's see. If a triangle is equilateral, a triangle is equilateral if and only if the triangle is equiangular, okay? If this, then that. All angles in an equilateral triangle are congruent, which means each measures 60 degrees. Okay, no problem. So, let's take a look down here. Find the value of x and y. Well, if this is 115, that means this one down right here, this is a linear pair. So this is 65. This is not an equilateral triangle. Okay? It is an isosceles triangle, so I know that x also equals 65. And I know that y, 65 plus 65 is 130, and all that's left for y is 50. Here, they're all marked congruent, so I know this is an equilateral triangle, which means I know the angles are all 60. So because I know they're 60, y minus 10 equals 60, so y is 70. And x plus 5 equals 60, so x is 55. Take a look here. Practice with equilateral triangles. Go ahead and pause the video right here, get some answers, and then we'll check them. Pause the video now. All right, let's see what we got. For the first one, for x, I got 20. For the second one, for x, I got 12. For y, I got 60. This last one here, this is false. I know it's false because this is 26. And then I can use, all triangles have 180 degrees. To find out that this is 76, and so that is not isosceles even though it looks like it. And that's it, guys. That's it for the notes. If you have any questions, make sure you wrote them down. Make sure you get them answered in class. See you next time. Bye.